welcome to my channel. Andy Rag here with another video, this time my latest project, the 4S4P LiFePo4 32 amp hour pack based on 38120 LifeBatt cells. This is my first video using a voiceover recorded during the video edit, so please bear with me. I'd like to give a big shout out to Julian White, Oscar Hotel 8 Sierra Tango November from Survival Tech Nord for giving me the inspiration to build this battery. Okay, let's begin. I'd been toying with the idea for building a larger lithium battery pack for my radio activities for some time, but the costs involved in acquiring a lot of new cells was a major factor preventing the build. So, whilst browsing a well-known auction site some time ago, I happened across a listing for 16 used 8 amp hour LifeBatt cells. They were at a very attractive buy it now price, so I thought I'd take a gamble and purchase the cells. Even though I had a bit of a road trip to go and pick them up, realistically this was the only way I was going to get a large battery build off the ground. Once I had the cells, the first job was to test the internal resistance of every cell to see how much aging had taken place. This involved charging the cells to capacity and measuring the ISR, or internal series resistance, for which my Turnigy AccuCell 6 80-watt charger was perfectly suited. I was quite surprised to see that all the cells were in really good condition, with the highest ISR being only 10 milliohms, indicating not much aging or heavy use. With this information, I was quite looking forward to seeing what the next step, capacity testing, would reveal. Let's take a look at the testing phase. Okay, that's the voltage, that's the amp hours, and that's the watt hours. So this first cell is still going strong above 3 volts. So far 6¼ amp hours. That's not bad for a used cell. Right guys, this is the little device that I've been using to test all my batteries. As you've just seen, I've got a couple of boxes full of what are they, 8 amp hour LiFePo4 38123 cells, 38 being the diameter and 123 being the length. So this is the device that I'm actually using to compare them all. It's the same device I've used for all the cells in the first box, and this is the third cell from the second box of 8 that I acquired over the weekend. So basically what's happening at the moment is we're running a discharge test on this cell here. As you can see, I've already tested the internal resistance, and that is 8 milliohms. And what I'm doing now is I'm doing a 1C discharge test down to 2.5 volts. So the display on the bottom is the discharge rate, which is 8. And the counter at the top, which is changing, as you can see, is showing, I'll wait for it to change, the volts at the minute 3.14, the discharged amp hours 1.4956, and the watt hours in 4.666, and it just keeps cycling round and round and round until the battery voltage will hit 2.5 volts, at which point it will stop and start beeping and record the final discharged discharged amp hours on the top display. So far this is the 11th cell, and it seems to be working quite well. You do need a 12 volt supply for this particular unit. That's the black cable coming off from the left hand side, with the usual 5.5mm barrel jack. And as you can see, I've got a simple wiring loom connected to the cell, just using some 12 AWG silicon cable to the power poles, and then some smaller cable. I think that might be 16 AWG back into the discharge meter. There's a fan which is active, and it does start running the moment you plug the thing in. But I'm led to believe, or I haven't observed this particular behaviour that it will speed up and slow down as the temperature on the heatsink there increases and decreases, and that is due to that little, if we can focus, that little doohickey on the left hand side. There we go, almost. Yeah, there's a I think thermistor on the side of the heatsink there, just monitoring the temperature of the heatsink there. There's other videos on this unit all over YouTube. I'm not going to go into a complete review, but so far my my usage of it has been quite good. It's doing what I need it to do. It's giving me what I would think what would appear to be consistent results for each of the cells. The ISR, the internal series resistance of the cells, I'm using the functionality in my Turnigy AccuCell 6, which is the device I actually use to charge the cells beforehand. So that's just a quick sneaky peek of my battery testing. Okay, chaps, see you soon. Okay, gang. So early today, I went on to repacker.com, plugged in all the numbers, and came up with that layout. You may have seen it on Facebook. So the next step is actually to assemble the individual packs. So that's the first pack. And we've got them linked in parallel, and they are currently under charge. Charging at 1C. Obviously, with the amount of capacity there, it's going to take a while. So we'll just let that charge away, and once we reach 3.6 volts, the charger will cut off, and we'll move on to the next pack. Once the packs are charged, I'm going to stack them on the tray there, so that we know which packs they are. So the first lot will go in positive side up, the next lot will go in negative side, positive side down, the next lot will go in positive side up, the next lot positive side down, and that will give us our 4S4P configuration. Okay, I'll bring you back when this charge cycle is finished. Right guys, that's pack 1 done. Pack 2 is now on charging. Oh, now charging, not on charging. There we go. I've adjusted the parameters on my charger just to allow a longer charge interval. It's still set at 2 hours, but it was set at a maximum charge of 8,000 milliamps. It's now set to 16,000 milliamps, purely and simply because when I put these cells back on charge, I put about half the capacity back in after the discharge test. So if you think about it, if there's already 4,000 milliamp hours ish in each of these cells, then we're going to need another roughly 16,000 milliamps to fill them back up. So that's what I've done. I can always restart the charge cycle, but there you go. Oh yeah, amplifier number 1 still going strong. So yeah, the reason why I'm doing these in the living room is so I can do other things and keep an eye on these batteries. Yeah, so that's one box done. And these things are the 4-hole plates that I've just turned up that were missing from the first order of bits and pieces. Right. So that's that charge cycle complete. Well, started again, and we've got another 8 to go after this pack. So stay tuned. Okay, that's all 4 banks of cells charged now. Now this is probably the most critical phase of building batteries, and that's actually building the battery, interconnecting all of the cells both in parallel and in series, because if you make a mistake at this stage you run the risk of releasing all the chemical energy within the cells, and believe you me, there's a lot of energy in there. So I think it's safe to say that the more time you take on this particular section, the better. So what I'm going to do is I'm just going to mark up the trays with how we intend to connect them, and that should help us in actually carrying out the connections using all those straps and plates. Okay. Okay. This is the pack now, marked up and ready for the initial connectivity. If I can hold the bloody camera steady. Right. So we started off with B minus here. Got B1, B2, B3, and B plus. So what they correspond to is they correspond to the balance leads that will go on the battery management board. Obviously, it doesn't really matter which terminal we connect the lead to, because obviously those are connected and at the same potential difference. Similarly here and here. But the other thing we've done is we've actually marked up using a Sharpie where the straps are going to be. So you can see that the battery banks here, 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 and here give us the parallel sort of capacity accumulation, and then the series connectivity here give us the voltage accumulation. Now just give me a minute and I'll just flip it over so you can see the other side. Okay, this is the other side. Point to note, there's no connectivity across the middle here. No connectivity across the middle of the pack, because obviously the connectivity flows that way and down, and that way and down, or vice versa. Okay, so there's absolutely no connectivity across the middle. If you do happen to connect the pipe across the middle, then you're going to short it and bad things are going to happen. So hence me being very careful and marking out the pack, and not just going off cock and thinking I know best. The other thing I need to point out is that you need to make sure that when you place your trays, you do so with the knowledge of the kind of connectivity that you're going to use. So if I was using just straps, for instance, just the 2-hole straps, the orientation of the spacers or the end plates wouldn't really matter. However, because I'm using the square plates with 4 holes, it does matter. So I have to make sure that there's nothing in that area there. You follow? Whereas if we turn the pack through 90 degrees, for say, and wanted to connect across this way with 3 plates, that post in the middle is going to be in the way. I mean, you could obviously Dremel them off, but it's much better to get it right first time. Anyway, what we need to do now is start assembling the pack. All right, I'll bring you back. Right then, as you can see, I've already taken some preventative measures and placed some tape over the terminals that I don't want to start messing around with. So what we've got here, we've got some of these 4-hole plates, and basically this whole section here is going to be strapped together essentially to produce the parallel connectivity and the series connectivity. So what I'm going to do is I'm going to pop these on here like that. And using the supplied 6mm studs, lock washers and washers, I'll pop these on like so. I seem to have misplaced my T-bar. Okay, found the T-bar, really useful piece of kit for doing stuff like this. Because you can just spin them in. Right, yeah, you'll notice if you look at the I can get this centre shot. I'm not right. You'll notice that some of these holes are actually eccentric. That's to allow a little bit of play between the holes. So that's why I'm not cranking down on the screws that are there already, just to allow us to get the holes lined up. And once we've got the holes lined up and everything's started off, then we can tighten up the screws. But it's important not to over tighten the screws at this stage, because A, you might have to take it to bits, and B, you might strip the threads out, and you don't want that. Right, so once we've got all 8 studs in, we can then just nip them up, not putting too much torque on there again. This one be what I'd class just tight enough. Right, okay. So there you have one half of the battery connected. So we're going to move this stuff over here and do the same again. Okay, that's one off the battery connected. Right then, what we're going to do now is we're going to flip the battery over and basically put some tape in place to stop us making any silly mistakes. Right, so what the plan is here is to link up the first and the last battery bank in parallel, and then the middle banks will be parallel and series connected. So if this is B minus at this end, the current will flow through this battery, using the plates on the bottom that we just assembled, across here, down through this cell, across there with the plates on the bottom, and then back up through here. That's the theory anyway. It should work. Okay, the last bit then is probably the bit where it could all go disastrously wrong if we've got any cross-connected cells, but I think we've taken sufficient steps to ensure that we haven't. Just make sure. Yeah. Right, okay, so let's just connect all these up in series and in parallel. Okay, this is where it starts getting a little bit fiddly. And you might want to forego the use of washers if your screws aren't long enough, because essentially you're using 2 or 3 times the thickness of plates to join together. This bit is the fiddly bit, because you actually, the middle bars, you can actually have 3 lots of bars. What I should have done maybe was used the square plates in the middle. There we go. 1. fully assembled battery. So at this stage we have our assembled battery, but what we need now is some interconnects. So this is what I've been using to charge all the cells. It's just a 12 AWG twin pair of wires with ring terminals and Anderson power poles on the end. What I need to do before we actually put the balance controller on is to actually level all the battery banks, because each of these individual battery banks has been charged separately, and there may be some discrepancies between this bank and this bank, or this bank and this bank, for instance. So what we need to do is do a final top-up charge, but use the balance program with a balance lead such as this one, so that we can make sure that all these cells are at the same level of charge, and then we can connect the battery management controller, and then relax a little bit, because we're nearly done at that stage. So hope you've enjoyed this little snippet. I'll bring you back shortly. Right, boys and girls, what we've got now is we've got a balanced lead. I don't know if you can see that. Oh, here we go. We've got the balance lead, and we got the charge connector. So what I can do now is I can get it back on the charger and just equalise all the cell voltages, ready for fitment of a BMS at some point in the near future. Right guys, as you can see, that's the battery pack, and at the moment we've got the charger connected, and at the moment the charger is running a balance program. If I just change the display, you can see there each of the cell voltages. So this is probably going to take a while. With a pack of this size and capacity, it's probably going to take a couple of hours to sort this out. So I'm just going to leave it running, keep an eye on it, and bring you back when we move on to the next stage, which will be fitment of a BMS. Okay, stay tuned. Okay, that didn't take long at all. The charge cycle is complete, and it only took about 10 minutes. So yeah, the pack, spin it round, wrong way. Pack is now complete. So in terms of the battery build, we're done. But we need to obviously add a battery management system now. The one I intend to use on this pack, I'm still waiting for to be delivered. I was hoping that they'd be delivered today, but they haven't been. So they'll probably be coming tomorrow or Monday, and then obviously we can make a start on wiring the thing up for external connectivity, and then obviously do a few tests. But that's this phase of the build complete. Happy. Oh, by the way, once we've got the BMS installed and the balance loom wired in, I'll be wrapping this thing up in Kapton tape to completely insulate it from the outside world, because obviously the potential for a short across those two babies is quite high at the moment. But yeah, all done for now. Cheers.